we have a talk about another talk on SQL-on-Accumulo. This is a collaboration between ClearEdge and Pivotal, and we're kind of excited about showing you guys about another way of doing SQL-on-Accumulo in comparison to the Presto talk that we had before. Thanks.
Hello, everyone. My name is Oren Efraty. I'm from Pivotal Israel site. I'm very excited to be here. Together with Zach from ClearEdge, we'll present you SQL-on-Accumulo with Pivotal HAWQ and PXF. So we'll go over HAWQ and PXF overview, the Accumulo connector usage, its advanced features, talk about the PXF API, what it means to implement a new connector, and then we'll have a live demo. So Pivotal was born out of EMC and VMware, focused on creating a new platform for cloud computing and big data, and it merged several lines of projects from its parent companies. One of them was Greenplum DB. Pivotal HAWQ is based on Greenplum DB. It's an MPP database, massive parallel processing database, runs on top of Hadoop. HAWQ natively reads and writes data to HDFS, provides linear scalability, and a complete standard ANSI SQL interface, designed to have no single point of failure. User data is stored on HDFS, ensuring that it's replicated. If a server failure occurs, it's removed from the cluster dynamically, while the system continues to serve queries. Recovered servers can be added back on the fly. So HAWQ runs on top of Pivotal Hadoop distribution. The distribution stack includes HDFS, Hive, HBase, Gemfire, and others. And of course, you can also install and run Accumulo on top of it. Most of the stack models use their own proprietary data formats and metadata. And as a result, it is difficult for other systems to access that data. We can see, for example, here two data formats. HAWQ, pictured in green, writes its own data format, Parquet, while another system, pictured in orange, for example, Accumulo, writes its own data format. So green writes green, and orange writes orange. Same goes for reading data fragments. HAWQ reads its own data format, and the other system reads its own. So something is missing in this picture. We need a parallel bridge between those different data formats. Let me introduce you with PXF. So PXF is a Pivotal Xtension Framework. It's a fast, extensible framework connecting HAWQ to a data store of choice that exposes a parallel API. Why is it fast? It's fully parallel, it's extensible. Users of the framework can easily extend it to write their own data store connectors. For example, the Accumulo connector, which is developed by ClearEdge and not internally in Pivotal. Data store of choice, any data store which exposes a parallel Java API, not mandatory parallel, but what's the point otherwise? PXF client is implemented using an external table interface in HAWQ, which allows you to read data stored within the Hadoop ecosystem. So now we see HAWQ on top of PXF, and we see how the magic happened. We see an orange arrow consumed by HAWQ. PXF allows you to directly read and convert another data format, for example, the Accumulo data format, which HAWQ doesn't know about. Direct analytics means the conversion is done on the fly, no need for data preparation or map-reduce jobs. But depending on the use case, you can also perform indirect analytics. You can see in the image the orange arrow coming to PXF and returning as a green arrow. The data was materialized and persisted into HAWQ's data format. Okay, let's go about the usage. So as we said before, we are creating an external table in HAWQ. We're specifying in the location clause PXF protocol, PXF host and port, the data source, which can be either file, a directory, or in case of Accumulo, the table name, and the plugin option. In case of Accumulo, it will be the Accumulo plugin. Format, usually either text or binary, and you can also specify segment reject limit. we can specify an error threshold to avoid aborting the query in case of errors. So how do you do the direct analytics? Simple. Select from indirect analytics, insert into select. We're talking here on fully featured ANSI SQL, joining with any other table, with HAWQ table, another Accumulo, or even HBase table that we'll see in the demo soon. Also support aggregation, sorting, can use statistical analytical functions from machine learning library Madlib. Let's now look at the Accumulo connector usage. As before, we are creating an external table in HAWQ. In the location clause, it will be PXF protocol, the Accumulo table name is the data source, and the profile will be Accumulo. This is the way to specify a binary format in HAWQ. So let's look at a more detailed example, create an external table with qualifier record key of type text, qualifier column family date of type date, and column family price of type double. The location will give PXF protocol, the instance of the Accumulo, the table name, and the profile Accumulo. And then we can easily select from Accumulo. We can even give a max function group by. It's important to note that Accumulo table can be very large in terms of number of qualifiers. We don't have to specify all of the qualifiers when creating the external table in HAWQ. Okay, let's go over some of the advanced features. Smart filtering with predicate pushdown. For example, if I have in the where clause a range of record keys, PXF can deduce where the relevant data fragments exist and exclude them from the irrelevant tablets. We can filter not only by record keys, but also by other qualifier values. Okay. Error tables for logging badly format data. For example, if I have data conversion issue, let's say a certain column is defined in HAWQ as an int, but one of the rows in Accumulo has a non-numeric value. We don't necessarily want the query to stop and abort. Lookup table for easy access. You can create a lookup table to translate between SQL standard and Accumulo standard. We can also run analyze on PXF Accumulo table. Using the analyzer, we can gather qualifier attributes data to help the planner, for example, in doing complex joins, so the query can be much more optimized. We have a mechanism for storing the remote credentials. The credential will be transferred to the connector at runtime. Okay, let's go over more advanced features. Visibility level support. The connector utilizes the Accumulo's built-in cell level security to ensure the users see only their data. Custom iterators for increased performance. The predicate pushdown is implemented using stackable iterators, which increase the comparison operation performance. There's intelligent range filtering. Specifying a comparison on a record key will modify the connector's range, minimizing the amount of data scanned. And last, automatic type detection. Data types are detected automatically within the iterator. Okay, let's talk about a little bit about the PXF API. The API consists of three main interfaces: the fragmentor, the accessor, and the resolver. The fragmentor returns a list of fragments and their location. The accessor then accesses this list, does the actual reading, and returns the records. And the resolver deserializes each record to be consumed by HAWQ. HAWQ query execution is divided in two high-level steps, the planning and the execution. The master process does the planning, while the execution itself runs in parallel on multiple segments. In the context of PXF, the connector fragmenter will get invoked by the master during the planning stage. while the accessor and resolver are invoked during the execution stage by multiple segments in parallel. Then the fragment's metadata returned from the fragmenter will be allocated for execution by multiple segments using PXF allocation algorithm. Each segment will then request the accessor and resolver for a particular set of data fragments, and they will reply with a structured representation of the records to be easily consumed by HAWQ. Okay, let's now look at the specific PXF API implementation for Accumulo. So we have the Accumulo fragmenter. The fragmenter will return Accumulo tablets and location. The Accumulo accessor will then access this list of fragments, read them, and return the Accumulo records. And last, the resolver will convert each qualifier to be consumed by HAWQ.
Add resolution. I'm going to show you guys a demo. I'm Zach from ClearEdge, and I created the PXF connector for Accumulo. So the things that I want to show you, I'm going to highlight some of the things that Oren went over earlier. But the first thing I just want to show you guys is I'm currently in the shell, and I'm in Accumulo shell, so I can actually show the data that I'm going to show you in Accumulo before we look at it through HAWQ. So if I get the list of tables here, the table that we're really going to concentrate on is connector. Oh, if I help spell it, all right? Connector test and do a scan. So I did a scan on this table to show us the data in this table. Most of us probably have seen Accumulo data coming from the shell, but it's just important to point out here that the brackets contain our visibilities. Right? So we have a field column that has no visibility, and then we have a field that you can have public or private visibility, a field that has public visibility, and only a field that has private visibility. So I'll highlight this later when I show user auths through HAWQ, but I just wanted to show the table. And I can actually show the user's auths in Accumulo by calling getAuths. As the root user, I have public and private authorizations. And as another user, foo, right, I just have public authorization. So if I query the table in Accumulo with foo, I could not see any of the private fields. The other thing that I wanted to highlight is when you're actually creating and configuring a table in HAWQ, you just need to set up the Accumulo profile and the PXF profiles.xml. So if we just look at this document, right, we have profiles for HBase, Hive in here, and at the bottom, we have our Accumulo profile, right? So all it does is it lists the class paths for our fragmenter, accessor, and resolver. Okay, with all of that set up, I can now open up pgadmin, and hopefully it won't look too bad. And hold on a second. There. So you can hopefully see the actual create table statement. Okay, so the first thing we're going to do is we're going to create a table in Accumulo. So here's our create table statement, right? We're creating an external table, and we're just defining our columns with types and names like we do in SQL, any SQL language really. And at the bottom here, we specify our location. And it's just important to note that for the Accumulo tables, when you are specifying your location, you have to specify your instance, then separated by a colon, and then table name. Because when you connect to Accumulo, it needs to know which instance of Accumulo you want to connect to. And the last part, our option here, is we're just using the Accumulo profile. So let's create our table. Right, if I highlight and run this, it says query returned successfully, which is good. The next thing we're going to do is we're actually going to run a query on our table. But to run a query on an Accumulo table, we need to pass HAWQ some user authorizations so that HAWQ can query Accumulo with the correct credentials. So I'm going to run these all as one query, but we can see here to set the user, we just set the PXF remote service login field and do the same thing for the password. So we run this. This actually queries our table. I'm going to make these a little larger so we can see the data that's coming out of our table. Right? But what's really nice here is all we did was a select star from our external table. And it gives us back the data as we would see it in any SQL query. So it's a very nice, easily presentable, field. And we didn't have to do much. We just created a table in HAWQ, and then we, let the connector do the work for us. So the next thing I do want to focus on is the use of the pushdown filters. So utilizing a pushdown filter is pretty easy. You don't have to do anything special. You just have to have a condition in your where clause. Pushdown filters for the PXF connector are actually implemented with iterators, and they are stackable. So when we run this query, right, we should get back a single record because we're just asking for the column named CF1Q2 to return something that's equal to 220. It's also important to note here that the iterator detects the type of data that it's going to do a comparison against, so it does the correct comparison. So it knows that it's comparing an integer, so it does an integer comparison. So if we did this against a floating point field, right, it would do a floating point comparison. Our next query that we have here uses multiple pushdown filters, right, not just a single pushdown filter. So if we see what we're actually querying here, we're making sure CF1Q2 is greater than or equal to 220, and CF1Q2 is less than 230, and the last column, CF1Q4, is equal to true, since it's a Boolean. So when we run this, we only get a few results back. Let me make this a little bit bigger. Yeah, so we can see all the results that we got back here, right? We were less than or equal to 220. Less than 230, and all of our results are true. So internally, what this is doing is this is actually pushing multiple iterators down on our Accumulo scanner for us and doing all the filtering on the server side before it even comes back to HAWQ for us, right? This, it's really just doing all the efficient work in Accumulo for us. So it's not happening on the client at all, it's happening on the server backend. The other thing that I want to highlight, if we've used Accumulo, if we have used Accumulo before, we know that the only way to really restrict the scanner that we're scanning for is actually to restrict the range of our scanner, right? Adding an iterator doesn't restrict the range of your scan. You're still doing a full table scan and filtering out data that you don't want. So in PXF, we can actually restrict the range of our scan by setting a condition on the record key, right? The record key in HAWQ correlates to the row ID in Accumulo. So if we run our next scan here, oops, I got to highlight all of it. If we run our next scan here and hit play, right, it actually restricts the entire range of our scan in Accumulo. I know you guys will not see this as a user, but internally what this is doing is it's making your query more efficient. So if you have pushdown filters and one of your conditions is actually restricting the row record key, it'll actually restrict the range of your query, so it'll make your query run pretty fast. The next thing I want to highlight here is that, right, we've been running this query as the user root with the root's credentials, and the root can see all of the fields we have in our table, right? One of the big things about Accumulo is the visibility labels. So I showed you earlier that foo had a different visibility than root. Foo only could see public data, whereas root could see public and private. So we're actually going to switch our login to foo, and sadly it has the same password as root. But when we actually make this query here, we're going to see that this last field here doesn't get filled in because foo does not have access to that field. So through the PXF Accumulo connector, we are using one of the main features of Accumulo, which is the visibility labels, without really any work. Accumulo is doing it all for us, which is really, really nice. So moving on, I don't know if you guys noticed this, but in our results down here, it's kind of ugly to have the column names being CF, Q1. What that really is that's our column family, then colon, then our column qualifier in our table. What HAWQ and PXF has implemented is they've implemented something called a lookup table to kind of solve this problem and put friendly names on things. In Accumulo, to create a lookup table, it's very, oh, and great, I get logged out here. So we have a lookup table, PXF lookup. Let's just take a look at it real quick. In our lookup table, if we want to create friendly names for our PXF table that we're going to look at, we have to have a table called PXF lookup, and in PXF lookup, the row ID has to be the name of the table that we want to map friendly names to, right? So connector test is the Accumulo table. Mapping is just the string that you must have in your column family. And then we have the friendly name in the column qualifier, and then the value is actually the column family, column qualifier in our Accumulo table that we're going to look up. So when we go back here, if we want to create a table that has friendly names, we have our same table definition, except we're actually going to have friendly names, not the column family, column qualifier names. I know it's it's actually very nice to make things readable for users. So, and now let's query our lookup table here, and the same, all the data is the same, except right, we have string, int, float, bool. Those are the friendly names that we actually used for our table. Right, and we can also use these friendly names in our pushdown filter. So let's just run a pushdown filter. Right, the pushdown filter is asking for the column float to be greater than 2.3, which it is, and it's asking for int, the column labeled int, to be less than 10, which it does contain. So the last example that we're going to go over here really highlights the flexibility of the PXF connector. I know we've been talking about Accumulo, but real quick, we're going to create an HBase table and look at some data in an HBase table. So we have the same table create statement. The only thing that's different here is that we're using the HBase profile. So we quickly create an HBase table, and there is very, very little data in this HBase table. I did this by hand, creating the data. It's running. I believe HBase is. Uh-oh. It looks like.
Is this why you would use Accumulo over HBase?
Yes. It seems like HBase is not giving me any results for the moment. So I don't believe I have time to restart HBase in front of you, and that's really not the point here. But it's not HAWQ's or ClearEdge's fault or Pivotal's fault that HBase isn't running right now. Accumulo is working fine. But what the last example is really going to showcase is that we can actually perform joins between different external stores. Right? We have an HBase external store. We have an Accumulo external store. When we would run this last statement here, right, we're selecting everything from two tables, which we're joining on the record key. We can join on any column, but it's just a single query that can bring multiple, external stores back to us. So that is really the end of the demo of the presentation. So if you guys have any questions, we would, love to answer them. Yes.
You showed the visibility strings. The visibility filter was working, but it only prevented the actual value coming back. It called the name of the field actually came back. So if your names are sensitive in nature, is there any way to filter that from coming back to the user?
That is something that I need to test and try and make sure that I remove the names from the columns coming back if 0 values. So, yes.
In your query where you have the predicate pushdown to the iterators, what if you used between? Would that push down as well?
So the question was, in the predicate pushdown, instead of using and, I'm guessing you're saying less than something and greater than something using between. That's a, it should work, it should push down things. Okay, yes, then it will push down the actual filter onto the connector. Yes. How is it? How is a join performed? Do you want to?
Well, the join is on top of two external tables in HAWQ. It's, so the join itself is done by HAWQ in the ANSI SQL. No MapReduce jobs are needed for it to execute. Yes.
So a lot of times when using a column-based database, there's thousands of columns, and you don't know the column names ahead of time. How does this language deal with that?
So, I mean, how I would deal with this is if you don't know your columns ahead of time, your table definition has to know the columns. So you just create a new table definition. But creating a table definition, you know, is very simple. So once you find out what the columns are, you just create a table definition for it. So it's, you know, you can, you know, grow as your data grows. So you're not actually creating any internal indexes or anything. Yes?
When you create a table definition, where is that stored at?
You know that one.
Yeah, it's stored in HAWQ metadata systems. No, you need to define it explicitly.
Are there any other questions? No? Okay. Oh, wait, one more. Okay.
One more, you know, in your HBase table, you guys can do a predicate pushdown only based on row key, right? But in Accumulo, you can push the predicates based on any column. So that's a big differentiator.
So I know a little, I didn't write the HBase connector, but I do know HBase internally supports some filtering, right? Whereas Accumulo, it had to be custom iterator done because Accumulo doesn't support any of that. So I don't know if HBase only supports row key predicate pushdown. So, okay. Thank you guys very much for your time.